Hi all, welcome to the first in this series of videos that's going to start to look at the last of the physical topics, so the last of the Unit 1 topics that we're going to be looking into, and it's the weather topic. Now, for a quick outline of what this topic is going to be looking into over the entirety of it, we are going to first have factors that can influence the weather in the UK, the different air masses that affect the UK, depressions, a type of weather system that's very common over the UK, anticyclones, which are the opposite to depressions, and forecasting, and how we actually forecast the weather and how this information is portrayed on synoptic charts. Now, to start us off in today's video, we're going to be looking at some of the different factors that can influence the weather. Now, largely speaking, we split this down into two subgroups. We look at things that can affect temperature and things that can affect precipitation. Now, at this point, it's worth me saying that we tend not to use words like rainfall, etc. when we're discussing the weather. We tend to stick to precipitation. Precipitation is a much better term. It's a bit of a catch-all. So basically, anything wet that comes out of the sky, we class as precipitation. So rain, hail, sleet, snow, etc. It's all gathered up under that umbrella. Now, when we look at the different things that can affect temperature and precipitation, you'll notice a lot of similarities in the two lists, where you'll notice that all bar one thing, they're in fact the same. So for temperature, we've got latitude, aspect, relief and distance from the sea. And then with precipitation, we've got, and I don't know why I put these the other way around, but relief, aspect and distance from the sea. So let's start looking at these and let's start to think about how they can actually influence some of the different elements of the weather. Now, first, temperature, latitude. Now, this diagram I've got here is fairly obviously a map of Europe, and it's showing you the global horizontal irradiation. Simply put, it's the amount of energy from the sun each of these areas gets as an average annual total. And you can see that the deeper red the colour is, the higher the value, and the closer you get down to blues, the lower the value. Again, we can see here that we've got much deeper reds towards the bottom of the map, towards the south, and then we climb up through the different colours as we go north, and we go through this in order. So it is a nice structured change, and we know that the reason for this, due to the Earth's shape, due to the fact that the Earth's a globe, it sticks out more in the middle along the equator, so that area is closer to the sun, and because it's closer to the sun, it gets more solar radiation, thus it's warmer. Now, as we move further north or south from the equator, and it's obviously north in this case, because we're looking at the northern hemisphere, we're looking at Europe, we see that it's not that the Earth's moving further away from the sun, but due to the curvature of the Earth's surface is further away from the sun, so the amount of solar insolation, the amount of solar radiation that we get is lower, so temperatures get lower as well. Now next, aspect. Now aspect's about which way you're facing. So we look at it this way, we've got a nice simple diagram here that shows you if you're in the northern hemisphere, you've got a hill, it's got a south facing side and a north facing side. Now because the equator is relatively to your south in the northern hemisphere, anything that's facing south is going to be heated more substantially than things that are facing north. And because of this, we see that south-facing slopes are a lot warmer than north-facing ones. It's also the reason why if you've got a south-facing garden, you'll find homes are worth more money. Now next, relief. Nice, short, simple. As you go up, it gets colder. I mean, we're really leaving it at that. We don't need to go into the physics, etc. behind this. It's just nice and straightforward. As you increase your height with respect to sea level, it gets colder. Okay, so next and last with temperature, distance from the sea. Now this is a bit of an odd one. The diagram I've got here is obviously like a map of Asia, and it helps to an extent, but there are a lot of ifs and buts in it. Now, as a general rule, as you go away from the sea, temperatures increase in terms of their severity. Now, that means that temperatures will both reach much higher maximums, but also reach much lower minimums. So the point that we make here is that the sea acts as a kind of normalizing factor. It balances everything out. It reduces the extremes that you experience in temperature. Now, if we start to think about precipitation, now aspect and relief we can kind of tie together here. Now, first, in terms of aspect, all I'm really going to say is that thanks to the way that the geography of the UK is, it just so happens that most of the rain we get blows in from the west, and we'll talk about why that is in a moment. And we also have most of the large mountains in the UK are along the west coast. Now this basically just results in the seaward side of these mountains experiencing most of the rain that we get in the UK. Now if we think about a why for that, relief is what this really comes down to. Now we can see here, you've got the ocean here, you're going to have moist air. It gets blown in by the prevailing wind towards land, and it hits the side of this hill. So as it hits the side of the hill, it's going to go up and up and up. As it does so, the air cools, the water in the air condenses to form clouds, and it rains. Now there is only a finite amount of water up here. Once it's rained out, it's rained out. Once it's pardon me guys. So yeah, once it's rained out, it's rained out. Once it's gone, it's gone. Now that results in a drier area after the hills, which is known as a rain shadow. Now if we look at this next diagram, it kind of marries up to what I'm saying. Now again, as a rule, precipitation, distance from the sea, the closer you are to the sea, the more precipitation you'll see. Lots of sea in that sentence. But the closer you are to the coast, you're going to have a lot more moisture. Now here in the UK, we see that most of our rain, which is the darker blue, occurs up the west coast. Now this is due to the fact that, one, as I said a moment ago, most of our weather systems blow in this way. They blow in from the west. Then they hit big bands of mountains. You've got the Snowdonia Range in Wales. You've got the Lake District here. You've got all of the Scottish Highlands, etc. This makes the air rise up, and it rains out over this area, which gives us a drier area on the east because it's the rain shadow that we spoke about earlier. Now, that's going to wrap up this video, guys. It's been a quick introduction to weather and some of the main factors that actually influence the weather we experience here in the UK. I'm going to put up another video today as well, so you should see this coming up as a two-part video. Please remember to watch the second one. It's going to be looking into the air masses that affect the UK. And I'll see you guys next time. Bye.